Okay, this video is continuing on in our beginner Civil 3D basic bridge design series. In the last video we created a generic profile for our roadway. Since then we've gone in and actually sized our bridge and run the hydraulics, and we decided on a 60-foot PC span bridge feature, which I've kind of drawn in here. Just note it looks a little bit skewed. Our Y direction is scaled up by a factor of 10 compared to the horizontal, so that's why that looks weird. But that helps us see our profile working a little bit better. But we've gone in and since had to raise the road up to accommodate the bridge. It's got these very deep beams, and finish the set profile. So from here now we're ready to move forward. So we have established a horizontal profile or a horizontal alignment, and we've established our centerline profile. So essentially we have a 3D georeference line along which our proposed design is going to follow. So the next step is to create a corridor based on a roadway assembly, which these are Civil 3D objects. The assembly is essentially equivalent to our typical sections. So we'll draw them in as a Civil 3D object and then bind them to our profile, so that gives us our elevations and our alignment. And so it will essentially create a corridor along the full length of our alignment based on the limits of our profile. And it basically creates a 3D model of our proposed design, and then how it ties into the existing surface based on all its features. And so that's what we're going to work through today. So the first thing we need to do is create an assembly. And to do that we need essentially tools to build our typical section. And where we get those, so if you come up here in the Home tab, there's our tool space here, but there's another box that we can click. It's right here. It's tool palettes. So we can also just type tool palettes. But these are all kind of like the pieces for building an assembly. So there's multiple tabs all the way through here for tons of different types of assembly features. So you could start here and have all the different, this is basic assemblies that has kind of preset, full assemblies across. But if you go in, there's basic lanes, shoulders, curbs, things like that. Those are the very generic ones, but you can get more detailed. So very specific types of lanes, with super elevation, tapered medians, shoulders, you can add shoulders, there's medians, curbs, all different types of curbs, your daylight, so outside of your shoulder area going down into your ditches, and then all kind of different links, and this will become important, how you link your widths and to different features, and how you can adjust your corridor throughout along your alignment. And so there's all different kinds of things, so it can get really, really complicated, but for the most part we're going to keep it fairly simple here. This is just a narrow, I think about 18-foot wide gravel road. Right now actually it's dirt. We're just going to be laying gravel, 6-inch gravel base, and we're going to put probably two 9 or 10-foot lanes with a couple foot shoulder, so we'll just gravel across the whole width. So what I typically do, just my general setup, so I have my design and my alignment here, and then I'll move over somewhere far enough away, and have my profile, and then I like to just draw a big circle and place my assemblies in here. Now I've copied over a couple from a previous project that has the same profile, or I mean, excuse me, has the same assemblies and bridge, just for reference. But this is essentially what you're going to be building. Um, and this looks very similar to a typical section. So we have our, here I had 10-foot lanes with a 2-foot shoulder. Coming from that, I have a side slope for 6 feet of a 3-to-1 slope. And then basically from there, and that's standard, so the purple or magenta lines, this is going to be standard for all the way along the profile. You will get this. Now these have links once you set it that will adjust to your existing ground surface. So if your existing ground is up here, this will only go down to match the existing ground. But if it, you can set further things. So we'll have now, this is our daylight link. And so what we have is, if you can go 6 feet at a 3-to-1, now I want you to put in a cut. If you're in a cut scenario, then I want you to put in a 2-foot flat bottom ditch and then come back up. Or I want you to fill the rest of the way down until you meet. But this is basically pretty standard of how we're doing it. But to build this requires a little bit more work. Obviously, if you have some already, just copy them over and adjust them. But what we need to do, we can come up to, this is our, remember this is on the home tab, but this is our design little section, I guess you can call it, which has all of our main object creating tools. Okay, so we're going to say assembly, and we want to create an assembly. So we're going to call this our typical one, so our main one, so center line. And so we can even decide it's divided or an undivided crowned road. Okay, so assembly styles, code styles, that's, we can do whatever on there. And assembly layers, it's up to you whether you want to set it on a layer to turn off and on, but again, it's way over to the side, so it's not really important to have it on a set layer. And hit OK, and so we just want to set a baseline location. We're going to set it under here because we're going to try to match this one. And all you get is this little marker here, and that's it. So I click on it, I'm going to hit type MO for properties, and now I've got an assembly. Here's its name, and it's on layer 0, and that's all there is here. So now what we need to do, and so essentially this is our center line marker, and I used a different style than this, so that's why they look a little bit different. But from here we can start building our full assembly. So if we go in here and look, now I want to put a lane, a traffic lane. And so what I'm going to do is I'm going to use this lane super elevation AOR. And you select the marker, the location where you want it to go. So this is our marker here. So now it immediately puts a lane over here. But that looks a lot different. It's got a lot of features, and you've got all these little circles. So this is, each one of these circles is a marker essentially for a location within this subassembly. So just some verbiage here. The entire thing that you build is the assembly. Each individual feature within that is a subassembly. And those are the features we can really manipulate. So I'm going to click on here, and now it shows this is a subassembly. And now it's got all of these features. So I could mess with things in here, or I could come up, now you know that this changed here, so we're going to go to subassembly properties. And now that pulls up this dialog box. So we could change the name, description, all that stuff, so you can get as detailed as you want. And it tells you the side. So now I want it to be, I think for this road, I'm just going to make it 11 feet. So that'll be a 9-foot lane and a 2-foot shoulder, essentially. So default slope, I do want a -2% slope. And now it's got all these different depths. So you can set pave 1, pave 2. So if you have an S3, S4 asphalt, you can set the depths of each of those, an aggregate base, sub base, all those different things. But what that does is, so you set that, so that's going to be the full depth of everything you're putting in. And we'll talk about this in the next video, but by the end you will have a surface that has the top of your corridor, so the top of your roadway, but also the datum, the bottom, because that's the point at which they need to cut down to or fill up to before you put your surface materials for your roadway. Okay, but we're only going to be just laying 6 inches of gravel on this thing. So we're going to change all of these to 0 except for the top one, and we'll put that at 0.5 because it's feet. So, and we're going to hit OK. And so now we've worked our way back to this. And so now I'm going to actually just keep going across and keep building. So now I want this set standard slope here. And so I'm trying to think here. Let's see what this one's called. So this is our link, width, and slope. So these are in our generic. So we have a link, width, and slope. So this is where it's a link that we're linking our roadway, and we're telling it we want a very set width and slope. So I click on there. Pretty sure I clicked that one. Yep. And it basically says select marker or point within the assembly. And this is where it gets kind of tricky, because obviously I want it to connect here, but if you look, there's kind of 2 circles, and because they're so big it's hard to tell. But basically this one is for the bottom corner, and this one is for the top corner of our roadway. So we're going to click on this one. Okay, and now we have our link. So right click, we're done. So what we want to do with this one, go back to subassembly properties, is we want to set it at a 6-foot width, and we want this to be a 3-to-1 slope, a -3-to-1 slope. So, but we need to express that in percentage, so that's a -33.33%. So we can hit apply, and now we can see that angle down there. And so that's going to be set. Now, what I want to do is add a daylight. And so let's verify up here. And this one's just a daylight general that we built. Okay, so I'm going to click daylight general. And here there's only one marker to attach to. So I can click it. And now basically your daylight will always give you 2 options, and one's for a fill scenario and one's for a cut scenario. And so we're going to click on this, go to subassembly properties, and you can see here there's all kinds of things you can fill in. If you go in down here for any subassembly, there's a help file that pops up, and this will show you, and it's really, really helpful, because what you can actually do is come in and set very specific cuts at very specific distances and slopes prior to allowing it to just kind of go on its own. So similar to what we just did, we could have set that all as a single thing. But what we want here is to establish our flat bottom for our ditch, and then allow it to go at a 3-to-1 in either direction. So we want a cut width be 2 feet, and we want that to be a horizontal slope, so just straight across. But then we're going to come down, and then once it goes through those cuts, it says you can actually set whether you're in a flat cut scenario, medium cut, or steep cut. you can actually vary the slope of those. So it can get really complicated if you want. We don't want that. We just want a 3-to-1 coming off of either of these. Okay, and we don't have any specific fill that we want, but we do need to set all of these fill slopes to be 3-to-1. So we don't have any of this. So you can set a guardrail width and slope, things like that. But right now we're going to omit guardrail. And then we'll just leave the rest alone. So we're going to hit OK. And so now what we have is a scenario where we have our 6-foot 3-to-1 slope, and then basically after that point it decides if I'm still in a cut scenario, I'm going to put a 2-foot flat bottom ditch and then go back up at a 3-to-1 to match existing. Or if I'm in a fill scenario, I'm going to continue down until at a 3-to-1 until I match existing ground. So this is our full one side of our assembly. Now, assuming this works, what we can actually do is just mirror this whole thing. I'm not sure if we can do it all at once. And we can hit a mirror command. So this is different from the typed in mirror command. This is very specific to your subassemblies. So there's copy, move, and mirror. So here we want to mirror, and so we need to select a marker point for the mirror. And we're going to hit here. Let's see if this works. So this did work all the way across. Okay, good. So the difference when you're doing subassemblies and you're actually selecting marker points, you're not necessarily selecting endpoints or general snapping points. You're basing it off of these markers, because for each subassembly feature, these markers determine the features of that subassembly and how it functions and works. And so that's why you're tying in. It's not an endpoint. These are flexible objects, and so they need to be tied in directly to each other. Okay, so now that we have created our assembly, and again we typed in typical 1 centerline, looks fairly similar to this. Again, these are different styles, and that's why they look different, but again, it's not a big problem. This just has all the markers within it. These have smaller markers. But now we have an assembly. So now what we want to do, we can clean this up, is apply this assembly to our alignment and our profile. And we do that through a corridor. So we come back up to our design tab, or design section on the home tab, and we're going to say corridor, and just click corridor. Okay, so we can name this whatever we want. I'll just do the project name, corridor. It's a corridor style. I'm not sure really the difference in those two, but it doesn't really matter. Corridor layer, we do want to set this on a specific layer because this is something we want to see a lot during the design, but we need to turn it off once we get to plan sheets and things like that. So we will set it to a layer, and there is a C road core layer for a corridor. Okay, and so this gets much more complicated because as you move along, there are multiple ways to set and build corridors. But for any corridor, you have to have a two-dimensional feature, so some type of horizontal alignment. It doesn't have to truly be an alignment object, but it has to be a 2D XY feature, and it has to have an associated elevation or Z dimension to it. So within our baseline type, we can set either an alignment and profile. So our alignment is our two-dimensional XY object, and our profile is our Y elevations. So we have We only have one for this. So I'll actually speak again. We want to set this to our finish ground center line for our profile. You can also use feature lines, which we haven't talked about yet, but these are similar to a polyline, um, but they're just a line feature that we can set elevations along. And so it acts as both an alignment and a profile kind of at the same time. So we have our center line alignment and we have our finish grade profile. And so now we want to select our assembly. So we just built this one. These are the ones I had previously brought in. But we'll use this one. And now we want to set a target surface. So we want to set that to our existing ground because we have our profile and we have our alignment, so we can create the base typical, especially for the roadway. But when we're thinking about our side slopes, our cut and fill, our daylight, it needs something to base this off of. And so we're going to set that to EG. You can go ahead and set some baseline and regional parameters for the corridor. We're not going to do that in this video. We'll do that in the next one. So we're going to uncheck that and just hit OK. And then now we have our corridor. So you can see it coming all the way down. Now you'll note here it kind of sticks out a little bit further here than right here. And it did the same thing along the end. The reasoning for this, so if you look, it started and it ran the corridor for the full length of our alignment. But our profile doesn't actually extend for the full length of the alignment. And so within our corridor properties, and we'll do this in the next video, we'll have to trim this up to make it equal to where our profile exists. But now this thing is essentially the 3D model of our typical section as it goes. So you can see here the reason it comes so far out is it's trying to get that fill slope coming down into the creek bed. So again, this is one single typical section we have applied. In future videos, we'll go through and set different parameters. For our corridor, we can split it into different regions, so each region can have its own set parameters. It can have its own assembly or typical section. We can say this is a bridge, so it doesn't have any daylight, it's just the road. And we can adjust this all the way along. We'll have to do some of that, setting the bridge, having guardrail widening all the way through, and kind of tying it into the existing. But for now, that's the basic corridor and assembly creation. And so I think that'll be it for this video.